Hello friends, this is Vinay BK. So today's session we'll be going to discuss about the problems on complex power. So before going to start with the problem, so let me discuss some few points you should remember to solve the complex power problems. So in terms of active and reactive powers, if you want to write active and reactive power, you can use this formula. Remember the formula is to solve the problems on complex powers. So if it is active power, so 3 into the bracket of 0 sequence power plus positive sequence power plus negative sequence power. That is nothing but VA naught IA naught cos theta naught, magnitude of VA naught into magnitude of IA naught, because power is a scalar quantity. So it is only having magnitude, so that you have to take the values of magnitude of 0 sequence voltage into 0 sequence current into 0 sequence power factor plus VA1 IA1 cos theta 1 plus VA2 IA2 cos theta 2 for all the three sequence components. And the next, if you want to write a reactive power, same thing, sin theta naught. So the second point you should remember to solve the complex power problem, if you want to calculate a complex power in terms of per unit, we all know that per unit is defined by the ratio of actual power, also actual value, to the base value. So here also the actual value of power is 3 into VA naught into IA naught conjugate plus VA1 IA1 conjugate plus VA2 IA2 conjugate, that we had done a derivation on complex power. That is the actual power of complex power divided by base power of complex power is nothing but VB into IB. So per unit is written as S divided by SP, that is the actual value of complex power divided by base value of complex power, whereas the base value of complex power is given by VB into IB. Similarly, in case in the problem, if they are directly given values in terms of per unit, then you have to use this formula. So this is a value of power when all the values of VA naught, IA naught, VA1, IA1, VA2, IA2 conjugate, they are given in terms of per unit, then you can use this formula. So total three formulas should remember: actual values, then per unit values. If the values are directly given per unit, then you have to use this. So let's move on the problems. So here the sequence components of phase voltages, they are given phase voltages VA1, VA2 and VA0. That is the sequence components of phase voltages. If it is a small a1 phase voltage, if it is a capital A1 line voltage. Sequence component, the positive sequence voltage they are given, a negative sequence voltage they are given, and the zero sequence voltage they are given. Similarly, they are given a line currents, positive sequence current, negative sequence current, and zero sequence current. So they were asked to calculate a three-phase power in kVA, is nothing but apparent power, nothing but a complex power. They are only given the base value as 1 kVA. Okay, so let us see the solution for this problem. So they are given all the values of VA1, VA2, VA0, as well as IA1, IA2, IA0, they are given. Okay, so what we have to calculate? We have to calculate per unit value as well as three phase power, S, actual power. So actual power formula we know, 3 into VA naught IA naught conjugate plus IA1 VA1 IA1 conjugate plus VA2 IA2 conjugate. VA naught they are given. So here VA naught is 20 at an angle of minus, sorry, it is 200, not 20, sorry, 20 only. Okay, let me see here. The substitution may wrong in this slide. So VA naught, they are given it as a 20 at an angle of minus 30 degree. So that 20 at an angle of minus 30 degree into IA naught conjugate. IA naught they are given 3 at an angle of minus 10. Conjugate is nothing but 3 at an angle of 10 degree. So I'll just strike out here. Substitute the values. Substitute the values what are they given. 3 into 20 at an angle of minus 30 degree into conjugate is 3 at an angle of 10 degree plus VA1 is 200 at an angle of 30 degree into IA1 is 20 at an angle of minus 10 degree. Sorry, they are substituted, but they were substituted first as VA1 IA1 conjugate plus VA2 IA2 conjugate plus VA0 IA0 conjugate. So that this is nothing but VA1 IA1 conjugate. First they were substituted, then they were substituted VA2 IA2 conjugate, then they were substituted VA0 IA0 conjugate. So that here 3 into, now we can see 3 into VA1 they are given 200 at an angle of 30 degree into IA1 conjugate. IA1 is 20 at an angle of 10 degree. Conjugate is nothing but minus 10. Okay, substituted. Similarly, VA2 is 60 at an angle of 60 degree into IA2 is 5 at an angle of 20. Conjugate is nothing but 5 at an angle of minus 20. Similarly, VA0 is 20 at an angle of minus 30 degree into 3 at an angle of minus 10. Conjugate is nothing but plus 10. So this is a value of actual power. So the total actual power we are getting, then they were asked to calculate per unit. They are given the base value. Per unit is given by actual power divided by base value. Base power is 1 kVA and we'll be getting the actual value as 12.13 plus J 4.62 divided by 1 kVA. We can get the value of power in terms of per unit. Very simple problem, just you have to understand. Substitution is very important. Keep your calculator in complex mode. Next, so in a three-phase system, the sequence quantities they are given VA1, that is a positive sequence and a negative sequence and zero sequence, and positive sequence current, negative sequence current and zero sequence current. Find three-phase complex power in per unit and in MVA. This is in terms of MVA, not MVA. MVA on a base of 100 MVA. They given the base values, no need to calculate base values, they are only given. Also compute active and reactive powers. Okay, so next, see here, there one thing you should remember, they are given all the values in terms of per unit. If all the sequence voltage and currents are in per unit, then we can use this formula. S per unit is given by VA0 into IA0 conjugate plus VA1 into IA1 conjugate plus VA2 into IA2 conjugate. Substitute all the values. So conjugate is nothing but, if IA2, if you want to write this as a conjugate, 0.9 plus J.1. Similarly, this is 0.2 plus J.1. This is 0.05 plus J.02 conjugate. So you can write here, instead of minus plus only complex values you have to write plus plus plus, then you can get the value of per unit power. Okay, then they are only given the base value is 100 MVA. Okay, so have to write base value they are given, per value per unit value have calculated, and also base values they are given. They were asked you to calculate three-phase complex power in per unit. We calculated in terms of MVA is nothing but actual value. We know that the per unit value is given by actual value divided by base value. Yes, per unit is given by actual value divided by base value. But here we already know the per unit value, we already know the base value. They were asked you to calculate actual value that is nothing but in terms of MVA. So that actual value is given by per unit into base value. So that per unit into base value we can get in terms of MVA. And also we have uh, complex power will be no, so that you can calculate of active power and reactive power. Very simple, just look at here, S is nothing but P plus JQ. So P is nothing but 81.7, Q is nothing but 31.26. So that active power in terms of megawatt, reactive power in terms of MVAR. So if you want to calculate, means you can use the formulas for active power 3 into VA naught IA naught cos phi naught plus, but here they are not given the value of cos phi naught phi 1 and all. Directly we'll be getting the magnitude, that is we will be having the rectangular form. Compare with the complex power equation, we can get active power and reactive power. And the last problem here, also they are given VA1, VA2, VA0 they are given, IA1, IA2, IA0 they are given. All the values are in per unit. They were asked to calculate per unit complex power, but they are given a condition that if the neutral gets disconnected, find the new power. First calculate per int value with the help of the given values, that is VA0 into IA0 conjugate plus VA1 into IA1 conjugate plus VA2 into IA2 conjugate. Substitute the values, then you can get per unit of power. The first step is finished. Find the complex power in per unit is finished. So the next second one is if the neutral is gets disconnected. Suppose if the neutral gets disconnected is nothing but current flows to the zero sequence component is 0, so that when the neutral gets open ia naught equals to 0, so that for this expression va naught into ia naught conjugate will be 0. The rest of the values just substitute and you can get the value of per unit of power, that is a new power. Okay, thank you.